365 metres, 2,800 rooms, 250,000 gross tonnes, 22 elevators. This building is absolutely massive, and it floats. But this isn't some New York skyscraper, it's the Icon of the Seas, the world's largest cruise ship. Forget the ideas of futuristic floating cities like in Korea or the Maldives. This one is happening right now, and it has the internet in a craze.
My only question is, where's there room for lifeboats?
Am I the only one who finds this terrifying?
If you thought building a structure on land was complex, try doing it on the water. There'll be 40 restaurants, a water park, 8 distinct neighbourhoods, and guests will be able to access their very own central park. At such a massive scale, it might as well be a skyscraper. It just happens to sail around the world with nearly 10,000 people inside it. This is how the world's largest cruise ship was built. 5 times the size of the Titanic and 35 metres taller than the height of the Eiffel Tower, the Icon of the Seas is a huge ship, to say the least. It's like if you took the Twitter building, laid it on its side, and put it in the ocean. Except this boat would still be 46 metres longer. When it sets sail in 2024, the Icon of the Seas will take the title from the current largest operating ship, the Wonder of the Seas, by an additional 3 metres and 2 decks. Construction's taken around 2.5 years, and it's all being built by Meyer Turku Shipyard, one of Europe's top shipbuilders in Turku, Finland. But before the massive construction process even began, designs were first tested in Royal Caribbean's high-tech renovation lab known as the KAPAL. It's a room-sized virtual reality simulator in Miami. Here, teams looked at renderings from all different angles before making final decisions. Once the design was finalised, working from the shipyard was finally complete. It all started with 2 long-standing maritime auditions, the steel cutting ceremony followed by the keel laying ceremony. Both happened in the dry dock, a sort of narrow basin that can later be filled with water. And the steel cutting stage is when, you guessed it, the first bits of steel for the ship are actually cut. Then, during the keel laying ceremony, the bottom parts of the ship are actually put into place. During the Icon ceremony, a 3,000-ton crane was used to lift a massive steel block into the dock. From there, the ship continued to grow upwards. Think of it as a giant Lego set or game of Tetris. Engineers built parts of the ship, including the 2,800 staterooms, block by block in a separate location in the shipyard. Each piece was then craned onto the dock and carefully stacked and welded into its final position, working from the bottom of the ship upwards. Now, that's different from how you build something like a skyscraper on land. While that process does start from the foundation upwards, the vertical beams shape the entire building as the skeleton structure, followed by the interior and then exterior finishings. And while the outside of a skyscraper is usually clad in heavy materials like concrete, glass or masonry, the Icon of the Seas is mostly made of extra strength steel and curved sheet metal. Those materials are all much lighter. One of the biggest challenges on the Icon was the Aquadome, a glass and steel structure that stands 25 metres tall and 50 metres wide, and is the largest of its kind on any cruise ship. The higher a heavy piece like this sits on a ship, the more it can affect stability and the ship's overall centre of gravity. Engineers conducted several tests during the design process to ensure it could work. To build it, 12 individual modules of steel, glass and aluminium were assembled together into one piece. In total, the dome has 673 glass panels. Once its rounded shape was finalised, a special rig with nearly 500 metres of suspension cables was used to move it onto the front of the ship. The final few metres of this move took more than 6 hours to complete. Then, it was finally welded into place. Over a period of 8 months, the Icon continued to come together piece by piece until it was ready to be moved out of the dry dock and into an outfitting dock. This is where technicians installed things like furniture and finishings. To do that, the dry dock was filled with water before 5 tugboats pulled the ship to the other part of the shipyard. After a few more months of work, the ship underwent its first round of sea trials, where everything from the engines to the steering system were put to the test in the water. The first trials lasted a few days and covered hundreds of kilometres. Another round is going to follow later this year. Now, we've kind of guessed what you're all thinking. How on earth does a structure this big actually float? And how does it operate? After all, this is essentially a massive skyscraper floating out at sea. Well, according to the science of buoyancy, an object can float as long as the amount of water that is displaced is equal to its mass. The Icon may be big, but the ocean is infinitely bigger, and there's a lot of open space on board that helps equalise its weight. As we said, materials like extra strength steel are used throughout most of the ship. And unlike skyscrapers, which use a lot of concrete or masonry, the combination of steel and air on the ship creates buoyancy because together it's less dense than the water under it. And inside the ship, interior design features like thin layers of marble finishings use less material than it would seem to the eye in order to keep them lighter. But really, it all comes down to one very important part of the Icon that largely sits underwater: the hull. Typically, smaller boats have a V-shaped hull. This design helps vessels reach high speeds and cut through choppy waves with less stability. Cruise ships instead have U-shaped hulls, which are wider and rounder. This helps disperse weight and water more easily with their larger size. It also creates more space for amenities, and while it does slow things down, it provides more stability, because nothing's worse than getting seasick from bumpy waves on a ship you can't get off. Skyscrapers take similar elements into account. When designing their cores, the shape affects a building's stability against wind loads. Instead of traditional four walls, taller buildings like the Burj Khalifa and Jeddah Tower use a Y-shaped three-walled core for further reinforcement. You might also be wondering how they keep the lights on for nearly 10,000 people out in the middle of the ocean. After all, this building can't connect to the electric grid out in the middle of nowhere. Instead, it relies on the Icon's 6 multi-fuel engines. Unlike other Royal Caribbean ships that use diesel power, the Icon will rely on liquefied natural gas. And in port, the ship saves energy by plugging into local power grids rather than leaving the engine on and burning extra fuel. So now we understand some of the scientific basics. How big could a cruise ship actually get? And is there such a thing as too big? After all, the Icon has already been labelled a monstrosity by some, and yet it's still set pre-booking records, so there's clearly a market for building these massive structures out at sea. But even if engineers do continue to solve the challenges of building big on the water, not all ports can take megaships of this size, and many have been banning such ships due to port capacity, pollution and over-tourism. So while the clouds have been the limit for many skyscrapers, the port size could be the limit for the future of cruise ships. And as we continue to push the bounds of engineering far into the sky on land, the future of cruise ship construction may not stretch so far into the water. Before we build the world's next biggest cruise ship, the construction sector might first need to build some bigger ports.